Welcome to BTEC Revision. In today's lesson, we're looking at energy in capacitors. By the end, we should be able to calculate the energy in capacitors. What do capacitors do? Capacitors store electrical potential energy. This energy can be transferred very quickly and depends upon the resistance of the circuit. And we can calculate this energy by this equation. Energy equals a half times charge times voltage squared. And the short form is E equals half QV squared, where V is the voltage, which is measured in volts, Q is the charge, which is measured in coulombs, and E is the energy, electrical potential energy, which is measured in joules. Capacitors are usually used in devices such as cameras or defibrillators, which require a large amount of energy in a short amount of time. However, capacitors don't store a large amount of electrical potential energy. Therefore, we can use a combination of capacitors and cells, depending upon the situation. Let's take a look at an example. A capacitor is charged to a voltage of 150 volts, and the charge stored is 30 microcoulombs. Calculate the energy stored. We can start by writing down our equation. E equals half QV squared. And now we can plug in our values. We know the charge is 30 micro, which is times 10 to the power of minus 6. And the voltage is 150. And don't forget the square. The 0.5 times 30 power 10 to the power minus 6 times 150 squared gives us a value of 0.3375 joules. Now pause the video here and attempt this exam question. A capacitor has 37.5 millijoules of energy stored. We can start by writing down our equation. E equals a half QV squared. And we have our values. We have energy. Energy equals 37.5 and it's milli, so you can convert that into the correct unit. So it's minus 3 joules. And we know the voltage is 50 volts. So what we can do is work out the charge. Even though it's asking for capacitance, let's work out charge first. And we'll have to rearrange this equation for that. So that would be 2 times energy equals QV squared. Rearranging for Q gives us 2 times energy divided by V squared. Plugging in our values, 2 times 37.5 times 10 to the power of minus 3 divided by 50 squared. And this gives us a value of 3 times 10 to the power minus 5 coulombs. Okay, now we have charge, we have voltage, energy, so for capacitance. So let's write down the equation of capacitance. We know from a previous lesson, Q equals CV. Rearrange for capacitance. Capacitance equals Q over V. And we have Q, which we've worked out, and V. So therefore, we can just plug in our values. So that's 3 times 10 to the power minus 5 divided by 50. And that gives us a value of 6 times 10 to the power of minus 7 farads. And it's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com. Try some quiz questions, and there's lots more resources available. See you next lesson.